Today we're going to be looking at two variable inequalities. This is section 2-8 in your book. It covers this one benchmark. The objective is that you will be able to graph a two variable inequality. The three vocabulary words that go along with this is a linear inequality, a boundary, and a test point. We will be using these vocabulary words to get through the lesson. So let's look at some examples. Graphing a linear inequality. What is the graph of each inequality? Let's begin with this one. We want our inequalities to be in y equals mx plus b form. This one is in that form. 3 is our m and -1 is our b. So we may begin graphing this one. We're going to begin graphing this one by starting with our y-intercept, which is -1. And then we're going to do our slope, which is 3 over 1. So we're going to go up 1, 2, 3, and to the right 1. We can do it again, up 1, 2, 3, and to the right 1. We can go the other direction by going down 1, 2, 3, and moving left 1. And if we do that again, 1, 2, 3, left 1, it takes us to the end of the graph. So now we're going to look at the inequality sign. Because this is not equal to, we are going to draw a dashed line through our points, moving from one end of the graph to the other. Make sure that your line covers the entire length of the graph. Next, we want to pick a test point to decide which half are we going to shade. This line that we drew acts as a boundary. We're either on this side of the boundary or we're on this side of the boundary. To determine this, let's pick a point. Let's stick with the positives and let's pick 2, 1. 2, 1 is clearly on one side or the other of the line. So we're going to use this as our test point. So we take the point 2, 1, where 2 represents x and 1 represents y. And we're going to plug it into our original inequality. 3y is greater than 3x minus 1. So 2 goes in for x and 1 goes in for y. So now it becomes 1 is greater than 3 times 2 minus 1. So this gives me 1 is greater than 6 minus 1, which gives me 1 is greater than 5. Since this statement is false, I'm going to shade the other half where my test point is not. Since my test point did not work, it is not in the solution region. So what I'm going to do is color in this half of the graph. Make sure that you color in all of that side from the line all the way to the end of the graph. Let's look at another example. (3y) is less than or equal to -2x plus 9. This one is not in the form we need it to be. So we're going to start by dividing everything by 3 so that we can isolate y. So we get y is less than or equal to -2/3 x plus 3. Now we're in mx plus b form, so now we can make our graph. So once again, that equation was y is less than or equal to -2/3 x plus 3. So we're going to start by going up 1, 2, 3 for our y-intercept. Now to do the slope -2, 3, we can go down 1, 2, and to the right 1, 2, 3. Remember, because the slope is negative, you can only do one negative. If we go down, we have to go to the right. So once again, if we do that again, we go down 1, 2, and to the right 1, 2, 3. Notice that I'm continuing my dots all the way to the ends of the graph, since I have to draw my lines to the ends of the graph. To go the reverse direction, we're going to go up 1, 2, and left 1, 2, 3. Repeat again, 1, 2, 1, 2, 3. This time, because this graph is less than or equal to, I'm going to draw a solid line through my dots. It's similar to what we did back in chapter 1, where an equal to gave a solid dot and a not equal to gave an open dot. For open dots, we use a dashed line, and for solid dots, we use a solid line. Once again, to decide where we need to shade, let's pick a point. This time, let's pick 0, 0, because once again, it is clearly on one side of the graph. So we're going to plug in 0, 0 to our equation. So we get 3 times 0 is less than or equal to -2 times 0 plus 9. So we get 0 is less than or equal to 0 plus 9, which gives us 0 is less than or equal to 9. 0 is less than or equal to 9. This time the statement is true, so we want to color in the side where that point is. So this time we're going to color in the side with containing that test point, which would be this side. Once again, make sure that you color in that entire side of the graph from the line all the way to the ends of the graph. So your solution region is anything on this line or all the way down to this end of the graph in the shaded region. Anything here in the empty region is not a part of your solution. So here's 2 problems for you to try. Try these 2 problems and bring them into class the next day to check your answers and make sure that you are doing them correctly. If you have any questions, write those down and make sure that you ask tomorrow. So that you can check your answers that you did with these problems, I'm going to go ahead and quickly show you the graphs for these 2. The first one is going to go up 1 with a slope of down 2 over 1. When you pick a test point, you can pick any point that you want as long as it is clearly on one side or the other. This line, because it's equal to, is going to be a solid line. And the shading for this one is going to be above the line or up here. Once again, you should be picking a test point of your choice that is clearly on one side or the other, plugging it into the equation to see does it create a true or false equation. If you haven't tried the other problem yet, pause the video so that you can try it, and then when you restart, I will put the answer up. For part B, you need to begin by dividing everything by 2 so that you get the equation y is less than 2x minus 3. So this time we're going to start by going down 1, 2, 3. The slope is up 2 and over 1. It's going in the opposite direction as the one we just did because it's a positive slope versus a negative. You can also go the opposite direction, which is down 2, and left 1. Because this one is not equal to, we're going to draw a dashed line through our points. Once again, you should be picking a test point somewhere above or below that line and testing it into the equation. This time, this shading is going to be down here. So once again, if you did not get these correct, write down your questions and bring them into class. Now let's move on to graphing inequalities with an absolute value. The other day we learned how to graph an absolute value equation. Now we're going to turn them into inequalities and add shading in there. So let's begin by looking at this problem. In order to put it into graphing or general form, we need y all by itself. So we're going to begin by adding 3 to both sides. Since over here I have an absolute value, I can't actually add 3 to anything. So it's just going to tack on to the outside the absolute value. And the equation will become y is less than 1/3 absolute value of x plus 3. Now let's look at the graph. There's only one translation in here, which is a move of up 3. Because there's nothing in here, we're not moving left or right. So our vertex goes up to 1, 2, 3 on the y-axis and becomes 0, 3. This 1/3 is our compression, which also acts as our slope. So from that vertex, we're going to go up 1 and over 1, 2, 3. Remember that absolute values have an axis of symmetry so that that point has a reflection on the other side in the exact same place. Then we can do that one more time by going up 1 and over 1, 2, 3. And then once again, reflecting that point on the other side. Now, because this inequality is not equal to, our V shape is going to be a dashed line. So we draw a dashed line through our dots, creating a V shape. This time, we're going to be shading above the V or below the V. So once again, let's pick a test point. I'm going to pick 0, 0 since it's nice and easy. And I'm going to plug 0, 0 into my formula. So I get 0 is less than 1/3 absolute value of 0 plus 3. The absolute value of 0 is 0, and 0 times 1/3 is 0. So now I have 0 is less than 0 plus 3. Add together 0 plus 3 and I get 3. So now I have 0 is less than 3. This is a true statement, so I want to shade where that point is, which means I'm going to shade below the V shape. Don't just shade directly below the V shape like this. You want to make sure that everything all the way to the end of the graph gets shaded. So that shading is everything on that graph below the V. Let's look at another example. All right, let's look at this example here. Once again, we need to isolate y. We're going to begin doing that by subtracting 1. Once again, we have to do it to the outside of the absolute value. We cannot change what is inside that absolute value. So now I have negative y is less than the absolute value of x plus 2 minus 1. Then I need to divide by a negative 1 so that I can get y by itself. When I divide by that negative 1, the inequality sign is going to flip to greater than. When I divide this absolute value by negative 1, it becomes negative absolute value of x plus 2. Once again, what is inside that absolute value did not change from the original. It will never change. It will always remain the same. Then negative 1 over negative 1 gives me a plus 1. Using what we learned before, we can find that our vertex is going to be negative 2, comma 1. The plus 2 is going to shift me to the left 2 as opposite, and the plus 1 is going to shift me up 1 as is. So vertex is going to be to the left 2 and up 1. This time our slope is negative, which means we're going to reflect in the x-axis or go down. So instead of going up and over, we're going to go down and over. Down and over. Since there's no number, we're just doing 1 over 1. And once again, there's an axis of symmetry here to reflect the points so that they have an equal member on the other side. This is not equal to, so we're going to draw another dashed line through our points to have a dashed V. Once again, please make sure that your lines extend all the way to the end of your graph. Even if your points do, your line needs to. So now we're going to pick another test point. Let's pick 1, 1 this time. 0, 0 is kind of close to that line, so you want to be careful there. So this is why I'm picking 1, 1. You don't want to pick anything too close to the line that can kind of be iffy. So I'm choosing 1, 1, and I'm going to plug 1, 1 in, and I can do it right here to this simplified version of the equation. So I get 1 is greater than negative absolute value of 1 plus 2 plus 1. Following my order of operations, I'm going to do 1 plus 2 to get 3. Then the absolute value of 3 is 3. But then I have to multiply it by a negative, so it becomes 1 is greater than negative 3 plus 1, which gives me 1 is greater than negative 2. This is once again a true statement. 1 is greater than negative 2. So I want to shade where that test point is, which means I'm going to shade everything above my absolute value V shape. Make sure that you cover from one side of the graph to the other, going all the way up to the top of that graph. Everything above that V shape needs to be shaded. Here's a problem for you to try. Try this problem, make your graph, and bring it into class to see if you are correct. Please have your questions written down, so if you don't understand something, you can ask a question tomorrow.